So hello, welcome. Thanks for coming today. Today we're going to be talking about A/B testing and how it can help you make significant improvements to your video product in a relatively short amount of time. So my name is Erica. I am head of partnerships and marketing at Streamroot, and I am with one of our founders and COO, Nikolai Radionov. To give you a little bit of background about Streamroot, which we'll go more into detail into in the third part of our presentation, Streamroot has developed a peer-accelerated delivery technology to help large-scale OTT portals reduce their bandwidth costs and improve quality of service. We're going to talk a little bit about our own A/B testing pipeline as an example in the third part of the presentation, so you'll get a little bit more information about what exactly we do at that point. We're going to start out today by talking about how to build an effective A/B testing workflow, when to test, what to test, and the different analytics pipeline that you should have, and some tips and tricks to do it right. We're then going to look at two examples of how A/B testing can be used very effectively to have very quick wins and to make big improvements in quality of service. The first example that we're going to do is a customer use case, actually a customer of ours, Dailymotion, that was able to make pretty dramatic QoS improvements with just a couple weeks of testing and iterating their ABR algorithms. And then we're going to talk a little bit about Streamroot as well and how we actually use A/B testing to constantly improve our product. So what is A/B testing and why do we use it? A/B testing, as I think most people probably know, is a way to test two versions, an A version and a B version, of your product or your feature. And it's essentially a way to be data-driven in your analysis. Instead of guessing, you can actually make very informed decisions by using the numbers actually in production. And so the great thing about A/B testing is that most often you're using a resource that is already at your disposal, and that's your own user data. So we're applying this today to video players, to HTML5 video players, and to quality of service metrics, but this can obviously be used for any number of scenarios. A/B testing doesn't always make sense, but it does when you can't test locally. So when you're dealing with a highly distributed or unmanaged networks that really can't be reproduced locally. So we're going to use the example of ABR algorithms with our peer-to-peer solution. Secondly, when you're deploying a completely new feature that's going to break with your current logic to see where any changes are coming from. And then anytime that you're going to be using a subjective hypothesis or magic numbers, I'm sure you've had to deal with this a lot. I mean, you've all done it when you're setting like a buffer to 10 seconds instead of 12 seconds and you don't really know why. This is a way to test what actually works in production. Before starting your test, you want to keep a couple basic principles in mind. The first is when you're defining your metrics, you're obviously going to be looking at something that's relatively complicated, especially if you're doing something in terms of user experience. So make sure that your success metrics are actually what you want to test. Are you trying to look for video play time, or are you trying to look for total session time? Which is more relevant for your business? For example, do you want to look at the number of rebuffering events or the total time spent rebuffering, or the actual number of milliseconds spent rebuffering during that session? And so make sure what you're testing is going to give you something relevant. And that sounds very, very obvious, but it is a mistake that actually a lot of people make when they think they're wanting to test for something that's not really relevant for their business case. Second, going along with that is to really define your variables, understand your variables, and make sure your testing isn't conditioned by a variable other than what you're actually trying to test. And of course, also make sure that an improvement to one metric is not causing any sort of decreases in the other crucial metrics that you might have. Third, you obviously want to determine an appropriate sample size and testing time frame depending on your use case, depending on your resources. And finally, you want to use identical populations as much as possible. When you begin testing, make sure you're doing it intelligently. If you're testing for quality of service on a video, you want to be using viewers that are on the same stream, that are in the same region, are using the same ISP, cetera, et cetera. You don't want to introduce any sort of discrepancy in the testing that could bias your results. So once you have all of that in mind, what do you actually need to conduct the test? Very simply, you need the right data, you need a database to store it, and some sort of analytics tool to be able to actually visualize and interpret your data. In terms of pipeline, that looks like this. So what we're starting out with, the data, the client metrics, this time we'll be using user data, and this is going to come in the form of player events. So buffering, playlist duration, et cetera. These can be easily calculated within the actual player or via a plugin that listens to player events. The second part of that pipeline is going to be your message broker. A message broker is a pretty simple service that receives the data from all of the different endpoints and then pushes it into a data store. And so the broker is only used for basically transmitting the data, but it's really, really important. It must always be up and available and running and able to handle and scale to your traffic, because it basically acts as a queue to allow you to transfer all of that data into your database, which takes a lot of time. And if your message broker goes down, you're going to have data loss. So it's an important component in that workflow. The third thing is your analytics database, which is going to store and aggregate your data. Should also be able to do any sort of sampling, filtering, slicing, et cetera. And then finally, because you're going to want to actually interpret your data, you're going to need some sort of visualization tool, analytics processor. This is also a really important part because you're probably going to want to be querying pretty often your database, and you don't want to have to have each graph take an hour to build. So you want a good tool that will allow you to interpret those results very, very quickly. This is what it looks like at Streamroot. So we use Kafka as our message broker and Druid as our analytics database, and we're going to go into a little bit more detail about that afterwards. These are not the only solutions. There are a lot of different solutions out there based on, depending on your use case, if you want to use open source or a proprietary solution. They're definitely not one size fits all, so do your research on those. Some of them are a little bit more cumbersome, and some of them are a lot faster, and get one that's adapted to your volumes and with what you actually want to do with it. Definitely do your research. We're not going to go into each one of them today, but if you would like more information about all of these different tools, don't hesitate to come to us after the presentation, and we can give a little bit more of an in-depth explanation of each one and why choose one over another. But just again, keep this, make it able to scale to your use case and have, be able to do what you want to do with it. So now we're going to take a look at how to actually build an A/B testing workflow and different things to do.
Yeah. So now that we have seen how to build the data pipeline, let's take a look at how to actually create the A/B testing split. So the concept here is very simple. Basically, you need to be able to give different versions of your player to different users with custom conditions that you can parameter and control. So there are several methods to do it. I'm going to talk to you about two of them today. The first is the dynamic config injection, and the second is basically provide different version or builds of your player via reverse proxy. So the first method is to create a service that injects a different configuration into your player and overrides the default config. So basically what happens is that instead of just bundling your configuration with the JavaScript player file, you make your player asynchronously request the config from an A/B testing broker service that is completely separate from your player build. And basically, that way you can customize the configuration file you send to each of your users, and you can make it depend on the stream they're watching, on the ISP or the city they're in, or any other parameter you want. So this method has a lot of advantages. The biggest one is that it's very easy to set up and use because basically you just work with a simple config file. It's also easy to deploy and to roll back frequently because it's a completely separate service from your player build. And finally, it's also very scalable because the only thing that this A/B testing service does is basically send a 20-line config JSON at the beginning of each session of your users. On the other side, being able to only change the config for the users, of course, gives this method a quite limited scope. So you can fine-tune your config parameters and even test new features via flags, but it's not a very good workflow because you don't want to have code that has a lot of conditionals and depends on a lot of flags. So you don't want to go too deeply into that for new features. But it's still a very, very useful method. And just a quick word on the implementation. Just make sure that if you do that, the config request is asynchronous and that doesn't block the player from actually starting to play the video while waiting for the new config. So the second method is to provide a different build version of the player by placing a reverse proxy in the middle. So what happens is that, for example, the user's requests like player.js, the reverse proxy will either add an A or a B at the end of the URL, depending on custom parameters you set up in the reverse proxy. So it can depend again on the stream they're watching or like some random percentages that you set up. So the biggest advantage, of course, of this method is that you provide, you can test completely different builds of your player, and so you can test major new features that actually break the logic of your old player. And even not talking about A/B testing, it's a very, very good method to make your new versions rollouts a lot more smoother by putting a new version on 10% of your users and 30, then 50, etc., and see what happens and if it doesn't break anything. And this is actually very good because it gives you a lot more agility and confidence in your release workflow. On the other side, of course, this method adds up some more complexity in the deployment process. So you really want to automate it to the maximum. And so if you do new releases every 3 months, it will take you too much time to build a new version just for A/B testing. So you really need to be able to deploy new versions in production every day if you want this to work great. And in terms of implementation, again, make just sure that the file request is not slower and doesn't add any latency with this conditional check. But yeah, just to clarify, both of these methods are good. And it's not a question of choosing one over the other. They are just adapted for different test cases. So at Streamroot, for example, we use both the config injection and the different builds. So to sum up this first part, here are a few things you probably want to remember from the first part. So first is that you should definitely A/B test when it makes sense and when it adds value. So it's especially useful in our case in adaptive bit rates or everything that touches the playback performances that you can't really easily test locally. Second, choose the metrics you want to measure in advance according to your use case. Third, build a pipeline and analytic tools that are actually adapted to your use case and volumes. And finally, use the A/B testing method that fits best your test cases.
So what can you actually do with a good A/B testing workflow? We wanted to start out with the example of Dailymotion. We've been working with Dailymotion for some time now. They've deployed our peer-to-peer solution on their platform, and we've also been able to do some other projects with them, including some of their player stuff. So Dailymotion, in a couple words, they're the second largest video hosting platform on the web today. They have over 100 million video views each day, which makes getting data very easy. And about 3/4, a little less than 3/4 of their desktop users are using the new Dailymotion HTML5 player. And this is where they were actually wanting to make their improvements to their ABR algorithms. So the experiment that they did was actually inspired by a presentation that we gave last May for Streaming Media East, where we talked about how adaptive bitrate algorithms work and how they are an extremely important and often neglected part of the workflow, and that they can have a very material impact on quality of service. So as part of our talk, we discussed some of the research that's been done about improving different the ABR algorithms that are in production today, and how it was, and we discovered that it was pretty simple to make very big improvements by just tweaking your ABR. So, however, it's not a one-size-fits-all type thing, so it's a great case for A/B testing. So Dailymotion was inspired by our presentation and decided to do some iterations on their ABR algorithms to try to improve quality of service on their live videos. So with an ABR algorithm, in order for the player to know what bitrate it should be streaming on, it needs to estimate the user's available bandwidth. And so this is not readily available to the player, so it's something it has to estimate. And in the simplest ABR algorithms, they simply take the size of the different segments or the different chunks of video, the time that the segment takes to download, the last segment has taken to download, and then they apply some sort of coefficient to get to the bit rate that the next segment should be downloaded on. This is what Dailymotion was doing in their HLS.js player. It works pretty well in production, but as you can imagine, network fluctuations, if you have just a couple seconds of a drop in bandwidth, you can kind of mess up the calculation. And unfortunately, if you're not estimating this bandwidth correctly, if you're systematically overestimating this bandwidth, you're probably going to get a lot of rebuffering. If you're systematically underestimating this bandwidth, you're going to be streaming on a low resolution for no reason. So they decided to take a look and redo a little bit this ABR algorithm that they had, the simple algorithm that they had. And one of the easiest things to do is not just to take the statistics from the last segment that was downloaded, but to use a range of historical segment data. So that's what they did for this. Next, you apply to that range of data an average or some sort of smoothing function in order to kind of eliminate any sort of outliers and to get to an average bandwidth available to the player. And then again, you choose a bit rate according to that. For Dailymotion, they decided to use the exponential weighted moving average, which actually takes into account all historical values and weights the most recent one much more heavily, and then they kind of decrease exponentially, as you can see. This was already used in Shaka Player. One version of this kind of average was used in Shaka Player there. So they drew inspiration from Shaka Player when building their own ABR algorithm. What was interesting in Shaka Player is that they have two averages. They calculated two different types of averages. The first one was kind of a fast average that would allow us to switch down to a lower bit rate very, very quickly if we had kind of a sudden drop in network conditions. And then we had a slower average as well that would allow us to slowly increase bit rate if we saw that network conditions were improving over time. So what was interesting in this is it uses two magic numbers for this fast and this slow estimate that basically correspond to how do I say it? Like how many seconds of history are going to be weighted a lot more heavily than all of the rest. And that's what those magic numbers corresponded to, essentially. So Dailymotion wasn't sure that this would actually work for their use case. And so they decided to play with these numbers and see what they could find. So before taking a look at the actual results of this, let's look at their workflow a little bit. Dailymotion was in a great position to do and is in a great position to do A/B testing because they are in control of their entire stack. On the encoding and distribution side, they have an extremely responsive server-side module that can inject different versions of their player depending on any number of conditions. They were also the creators of their video player, HLS.js, so they knew the inner workings of it and knew exactly how to tweak it. And then they had actually built their entire analytics stack as well. So they really had, everything was done basically in-house, and they're in control of everything. And that really allows you to have a lot of flexibility, to roll back very quickly, and to test with a lot of flexibility, and to not be afraid of breaking anything in production. So here are the results. This is actually before any of these changes were made. What we're looking at here is rebuffering percentiles. So we're looking at the number of plays that had 0 rebuffering events, 1 rebuffering event, 2 rebuffering events, et cetera, et cetera. And so as you can see, HLS.js in the middle was actually underperforming compared to its Flash counterpart for their live video. However, after Dailymotion applied the exponential weighted moving average algorithm, what we saw was a nearly 10% increase, a 9% increase in improvement in rebuffering. And as you can see, they used the different magic numbers of the S and the slow and the fast. And what we've done is improved by up to 79% of sessions with no rebuffering, with 0 rebuffering incidents. 9% is really huge, and they were able to do this by testing on like 20% of their population for 2 weeks. So it's really quick, and they were able to make huge improvements in a very short amount of time. These are not the kind of improvements that you can just make by changing CDNs or anything. This is really, really huge for them. So of course, this is all well and good, but what about all of the other metrics, the other quality metrics that we want to look at the same time? What about average bit rate, about track switches, et cetera? Unfortunately for Dailymotion, they saw that this algorithm, their new algorithm, also improved, also diminished the number of track switches compared to their previous algorithm, and that average average bit rate was either the same or improved. So just to wrap that up, just to say, with the right workflow, you can make big improvements with just a few weeks of testing. They were able to make significant changes, and these changes are now in production today. And Dailymotion is always testing. I mean, they're always experimenting and always testing different metrics to improve quality of service. But again, these numbers are always use case specific, which is why you need to use A/B testing in these kind of situations. They're going to depend a lot on your segment length, your use case, whether live or VOD, your network conditions. Dailymotion's an international, worldwide platform, so that also made a difference in their testing. But again, what to retain is that you can actually have very quick wins pretty quickly. So moving on to maybe a more, the other side of the coin, a more like vendor perspective perhaps, we wanted to look at how Streamroot actually uses A/B testing to constantly improve its own video delivery solution. And for those who do not know Streamroot, as I mentioned, we do a peer-to-peer delivery solution that allows large broadcasters to reduce their bandwidth cost and improve quality of service. So what we do is, instead of getting all of the content from a CDN edge server, users watching the same content at the same time can obtain direct segments directly from other devices that are watching the same stream. And we do that securely through the WebRTC protocol. And so we create this pretty widely distributed delivery network that's much more efficient, especially when there are big spikes and big live traffic. So as you can imagine, we have a lot of things to measure and a lot of things to take into account. We're basically creating a system in which we're kind of multi-sourcing content. Each user is getting segments of video from a variety of different places. So we have to make sure we're doing the best connections, that we're correctly balancing the load between the CDN and the mesh network, really just trying to get the best connections possible and have the best improvements in quality of service thanks to this. So to do that, we have been doing research and development for the last 4 years, and we have a pretty solid solution, several patents. But at some point, to really improve and to make those marginal improvements, you have to do A/B testing. And so today we're doing A/B testing on a dozen different metrics that measure our peer-to-peer performances and also QoS. So we'll take a look at some of those.
Yeah, so let's take a look quickly at our pipeline. So our JavaScript library, peer-to-peer library, is integrated with the player on the client side. So that's how we actually get our data. Then we, as we said, we send it to Kafka. So Kafka is a very, very scalable and highly performing message broker that can deal with like millions of messages per second, which is a scale we need at Streamroot. Then we put all this data into Druid data store. So Druid is basically a very scalable data store that was designed to easily answer queries with a lot of different dimensions and metrics. And actually, it's used a lot in machine learning. And then we plug in Caravel, which is like a dashboard solution built by Airbnb that gives us the flexibility to do queries on our A/B testing almost in real time. So it provides us a lot of agility and feedback, easy feedback on our A/B testing. And also, sometimes we need to do like more deep statistical analysis, and for that we can also plug in languages like R or MATLAB into it. And on the actual A/B testing setup, as I was saying before, we use both the config injection method and also the other method that basically can provide different builds of our module to different users. So one of our latest iterations targeted the process of requesting segments from another like device or what we call peer. So when asking a new segment of video from another user, the user must first ask the other device if it actually has the segment or not. And so we have a timeout parameter to determine how long the user should wait before asking this segment from another device if the first one basically disconnects from the network. And so we did a simple A/B testing on this timeout parameter. And so if you take a first look, like at first sight, what we saw is that changing, like having longer or shorter timeouts actually doesn't do basically anything to our solution. The peer-to-peer efficiency here stays around the same. But what's very interesting is that if you look a little closer and deeper and splice the population by the type of the stream, so like here we did for live and for VOD, you see that actually for live, the shorter timeout value provides like 1.6 more % of peer-to-peer efficiency. And on the contrary, for VOD, the longer timeout gives like plus 2% of peer-to-peer efficiency. And when you think about it, this result is quite logical because in live you have a limited number of segments available, and thus you have a shorter time frame to ask the segments from different peers. But in VOD, you have a lot more time to actually pre-buffer the segments, and so you can be more generous about the time frame. So with this very easy example, we saw that basically it's very important to know your data and to be able to splice your population to take into account the specificities of your use case. So check the results by live VOD or mobile, desktop, etc. But what is even more interesting in this example is that we actually, before doing this A/B testing, we didn't think that the timeout parameter could actually vary depending on live or VOD. So we actually learned something new about the solution we provide, and we learned a new way to improve it. So today we actually have like a dynamic timeout set that depends on the buffer size of the player. And of course, you could say that 2% improvement is not that huge, but take into account that we did that in only 4 days, and we are doing like dozens and dozens of experiments every week. And so, of course, after a few months, you really see like material improvements, be it here in peer-to-peer efficiency, but also like in QoS or other metrics that you apply your A/B testing on. And so to sum this all up, first I want to say that, yeah, we already said it several times, but really you should understand and know your data, how to calculate your metrics, what they really mean, and actually you will see that you will need also to like question yourself often, because it's very easy to make the data say what you want it to say, basically. So like you really need to question yourself often to see that if you're going in the good or wrong direction. Second, as we saw, A/B testing is sometimes the only way to actually prove your hypothesis and just stop like guessing. Third, sometimes you will see that the A/B testing will not have the effects you wanted, and so in that case, you really need to be able to roll back quickly to remove the A/B test and basically plug another hypothesis or another value for your A/B testing parameters. So that's very important to have a good rollback solution. And finally, basically, in A/B testing, what is, I think, the most difficult is to basically build the pipeline, the data pipeline, and the A/B test setup. But once it's done, you will see that it really changes your way to code, your way to improve your product, and actually like the way you see your product. And so when it's set up, really you should test like every week and be relentless about it. And of course, you don't need to be like Dailymotion or YouTube or like Streamroot to do that. You can set up an A/B testing workflow with quite simple and open source tools. So I really advise you to try it, and you will see that in the long term it will really benefit your end users. Thank you very much. And if you have questions. Yeah.
So when you do the A/B testing, do you notify the customer or the users that you are doing testing, or
for us? Yeah. Our customers, we tell them if we're doing the A/B testing, and we also do it either like on a small part of the population of the users, or like a small part of the stream. So often we just do an A/B testing on one stream out of like 100, basically.
Do you only ever do 2 versions at a time?
Do we do more than 2 versions at a time?
Yes, because having more than that is more difficult. For us at Streamroot, it's difficult because we need enough people to have good peer-to-peer. So we don't want to like separate in like 20 different clusters of users. But even for I think Dailymotion, they also do like 2 versions at a time, because you don't want to have too many parameters to compare, basically.